Welcome back to the flipped classroom. Our topic today is exponential regressions. Now that word regressions may sound familiar. Back maybe a month or two ago, we talked about linear regressions, and this is quite a bit of calculator work. So if you don't have your calculator right now, you better pause it, go grab it, and hopefully we'll get all these buttons down. So regressions are used to predict values. Okay, and we have these things called correlation coefficients, so this should be a little review. We have talked about this before. Your correlation coefficient on your calculator is denoted by the lowercase r. Now that value r tells you if your two functions, or two variables there, are related very strongly or weakly. So that correlation coefficient r has to fall in between +1 and -1. So hopefully you'll recall, we said the closer you are to your 1 and -1, the stronger you are. So the closer you are to 1 would be a strong positive, closer to -1 would still be strong, just a strong negative. Now you get a lot weaker when you get close to that middle number, and the middle number between -1 and 1, of course, is 0. So the closer you are to 0, the weaker you are, the weaker the relationship between the two variables. So there's 4 different types of regressions that we cover in this course, and like I said, we've talked about the linear regressions, so let's quickly review linear. Linear obviously comes from that word line, so the equation looks like y equals mx plus b. And when you graph it, you get a nice line. The other types of regressions are going to be new to you, and hopefully these words sound familiar. The first one is exponential. And we've been talking about exponentials all week. And this equation is going to look like y equals ab to the x. And you can think of that when we did our exponential growth and decay. And hopefully you can recall what an exponential looks like. Exponential grows really fast. Okay, growing exponentially, you may have heard that term before. And it's going to pass through this point 0, 1 most likely. And again, this function is growing very fast. And it has a horizontal asymptote at y equals 0. The third type of regression we're going to talk about is the word logarithmic. And, obviously we've been spending quite a bit of time on exponentials and logs the past few weeks here. And that equation is going to look like y equals a plus b ln of x. So it's going to have a log equation in it, a log, natural log, or common log right in it. Now this function is the inverse of an exponential. So remember, inverse means opposite. If exponential grew really, really fast, then inverse is going to grow really, really slow. Okay? And it had, again, the opposite of the exponential. Here in the exponential, the asymptote was on the x-axis, and in the log, the asymptote is on the y-axis. And remember, if the exponential passed through 0, 1, the logs better be passing through 1, 0. Inverse, switch the x and y. Now, the fourth and final type that we're going to talk about is the word power regression. And that word should be pretty new to you. And that equation will look like y equals ax to the b. Now its graph most closely resembles that of an exponential. It just doesn't grow as fast as the exponential. So I'm going to go ahead and draw that in. And remember, the exponential grew super fast, so it would have gone up like that. But the power is going to look sort of similar. So I would definitely say you want to familiarize yourself with these graphs. If we say sketch an exponential, hopefully you could easily sketch this graph that grows very fast. If we said sketch a logarithmic function, hopefully you could quickly just sketch, a random function that grew really, really slow. So let's try to get those in our memory bank. So let's go ahead and dive into our first problem here. All right, the data at the right shows the cooling temperature of a freshly brewed cup of coffee after it is poured from a brewing pot into a service cup. The brewing pot temperature is approximately 180 degrees Fahrenheit. So here you can see they've got the time in minutes, and it's labeled, and there's your time. We've got our temperature in degrees Fahrenheit. So I just want to be clear, you probably don't need to copy this whole thing into your notebook right now. The math down here is going to be more important. But I want to be very clear. On these tables, whatever they put first is going to be your x variable, and whatever they put second is going to be your y variable. Okay, so again, x is first, y is second, every time. So remember, this is all calculator work. You cannot do this in your head. So I'm going to write the steps out, and if you're familiar with it, that's great. Remember, we did those linear regressions a little while ago. So in order for me to enter this data in the calculator, you're going to hit, and I'll box it in, that stat button, and edit. Okay, and at the top of your screen, you should see L1, L2, L3. You're going to carefully enter all this information in L1 and L2. So the 0 goes in, the 5, etc., the 179.5, etc. You're carefully typing all that in. Now it's important you do take your time when pressing those buttons. If you screw one number up, we really can't help you. There's no partial credit there. You just got to take your time and make sure you've typed them all in correctly. Now after that's all in there, you're going to go back to Stat, arrow over to Calc, and now you have a whole slew of things to choose from under Calc. It starts at 1, and if you just keep arrowing down, it goes A, B, C, D, etc. And our goal, those directions said we wanted an exponential. So if you scroll down till you see something that looks like exponential, I believe it's at 10 or 0. It looks like it's written as a 0. It should say EXP regression, and that stands for exponential regression. All right, so after you choose that, it should appear on your screen, EXPREG. And after that, you need to tell the calculator where you put this information. Now, I put mine in L1 and L2, so I'm going to hit L1, comma, L2. To find the L1 and L2, that's your second 1 button and second 2 button. All right, so after I've entered that, you can see what appears on my calculator screen here. Now, if you don't have the R values, we can help you with that tomorrow in class. Basically, if you just go to your catalog, you need to turn the diagnostics on. But again, if you don't have those at the moment, that's okay. And I'm just going to scroll back up to my directions here. It said, oops, I think I lost them. I believe it said write the exponential regression to the nearest hundredth. So the first thing you should make note of is they tell you the equation right there. Y equals AB to the x. So jot that on your paper. Now they basically do all the work for you. Now they're going to tell you what A is, and you're just going to plug that number into A. Make sure you substitute with parentheses, of course. And we're going to round to the nearest hundredth. So that's 171.46. Then they'll tell you what B is, and again we're going to round to the nearest hundredth. So that's 0.99 raised to the x. So the calculator is going to give you all the information you need, okay? And basically, that was part A, just to write the equation of the exponential regression. So we put the information in our calculator, choose exponential regression, and bam, we've got it. All right, part B is real friendly. It says predict the temperature of the coffee after 40 minutes. Okay, so we're just going to use the equation we wrote, and I've got it right above there. And it should be really straightforward. It's usually right in front of your face here. If you notice, they'll tell us this x value, remember x is first, is the word time, and y is the word temperature. So basically, you just have to determine, are you looking for the time or the temperature, and which one's giving to you? Well, it says predict the temperature. That means you don't know what it is. So you are looking for temperature, which is the y variable. So I'm going to say that's y equals 171.46 times my 0.99. And now the x stood for the minutes, and they tell you 40 minutes, so I'm going to substitute in the number 40. Now this is plug and chug. Go straight to your calculator. Do not try to do this in steps. Do not type in this times this to the 40th. I want you to type it in exactly how you see it, no shortcuts. And when I type that in exactly as I see it, I get 114.701, etc. And I can say to predict the temperature, I'm going to say that's degrees Fahrenheit. And now they'll normally tell you what to round to from there. Okay. Alright, so part C is going to require a little bit more work on our part here. It says predict the time if the temperature is 130 degrees Fahrenheit. So again, there's one thing they should be asking for, one thing they want to know. And recall, whatever is first is X, second is Y. So predict the time. That's the one you don't know. If the temperature is 130 degrees. So they're telling you the temperature, and if you read your chart, temperature is the Y. So they're telling you the Y. So instead of saying Y equals, I'm going to say 130 equals 171.46 by 0.99, and I'm predicting the time, so that's raised to the X. Now we practiced solving these just a few days ago. Remember, this is called an exponential equation because we have an exponent. Okay, so I want you to box in the base with its exponent. And what I'm saying is this exponent of x is only sitting on the 0.99, not the 171.46. So box that in. So in order to solve for that, I need to first isolate it. So I'm going to divide both sides by the 171.46. And again, straight to the calculator. So you'll notice I got 0.75819, blah, 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 blah. And I'm going to store that into A right away, just like we did the other day. And now, because this is an exponential, because of that exponent, I need to take the log of both sides. And I'm going to use ln. It doesn't matter if you use common log or natural log. And when I put the ln in front of the 0.99, it's going to take that x and bring it down in front. That's that law 3. And now just to get x by itself, I'll just divide both sides by the ln of 0.99. So I should get x equals, and I've got 27.542, and of course this is minutes that I just found. Okay, so there you have it. We're going to throw a bunch of stuff that we've talked about the previous week all together tonight. All right, question 2. This is going to have a couple parts to it. So based off this table on the side here, question A, which is new to us, it says determine which function will best model this data. Now, the one that's going to best model it is the one with the strongest correlation. Oops, Bailey. So in order to determine which one has the strongest correlation, I have to compare the correlation coefficients, which we reviewed earlier. And remember, the correlation coefficient is that lowercase r. So this takes a few moments. I have to bring up the linear, the exponential, the power, and the logarithmic, and compare their r values to see which one is the strongest. Alright, so once this data is typed in your calculator, okay, you've got your L1, L2, the first thing we're going to pull up is the linear correlation, and we're going to type in, or write down, our correlation coefficient. And I've got a point, I'm going to go 3 decimal places, 0.943. So I would say that's pretty darn strong. 0.9 is certainly close to 1, strong positive relationship. Now let's see if we can get any stronger. So you don't have to retype these in, clearly they're in there already. We're just going to go to our home screen and do our stat, arrow over to calc, and this time choose exponential. When I pull the exponential, I get a 0.863. Now I'm going to scratch that one already because that's already less than the linear. That is not the strongest. And then we'll go get the power. So again, just pull up a power regression. So your power regression is still in that list under stat, arrow over to calc there, and look for something that looks like power. I think it's close to the A. And I've got a 0.962. So that beats out the linear, so I'm going to scratch the linear. The last one I have to compare to is the logarithmic one. Now let's make a note in our book here. There's 2 that kind of look similar to the word log when you scroll through that list. You are specifically picking the natural log regression. That's the only one we're going to use in this course. Okay, so make a note. You are choosing the one that looks like natural log regression. I believe it's on number 9. And this time I get 0.992. So we have a clear winner. The best one that matches this data is logarithmic. Alright, so what that's telling us is our data should go in the form of a nice slow growing graph of a logarithmic. It's going to look something similar to that in shape. So let's go ahead and write our equation, and we'll write it out to the nearest hundredth. So if you read your screen, It'll say on that top row y equals a plus b ln of x. I took a picture of my screen here. It's a little blurry, but hopefully you get the idea. So I'm just copying that y equals down, and then I'm just going to plug that variable a in as 2 point, and I believe we said nearest hundredth, so 2.11. Now my equation has a plus sign, and now it wants the b value, and like I said, nearest hundredth, so 6.28. And we're going to keep the x, so ln of x. And there you have it. That is our linear regression, or logarithmic regression. All right, last question for the night, probably one of the tougher ones here. It says if y equals 10, predict the value of x. So I'm clearly going to plug 10 into the variable y. So I've got 10 equals 2.11 plus 6.28 ln of x. All right, now remember, my goal is to get this ln of x by itself, so I'm just going to slowly move things over. I'm first going to subtract my 2.11. So I got 7.89 equals 6.28 ln of x. And again, still want to get this by itself, so now I'm just going to, you've probably guessed it, divide the 6.28 over. And I'm sure to get some ugly number on this side, so whatever I get, I'm going to store into a. So I'll tell you what I get anyway here, and hopefully you're getting the same thing on your calculator. I've got a 1.2563, blah, 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 blah. And again, I'm just hitting store into alpha a, and I'm going to call that a. So just a few quick steps left. We're almost done here. All you have to say to yourself is, I'm currently in log form. And in order to get out of log form, I have to convert myself to, you've got it, exponential form. Okay, and basically I'm just going to start with that base e on my ln and draw those arrows in. You can't screw it up. Start with the base and draw the arrows in. Oops. So I'm going to say e to the a equals x. And I'm literally going to my calculator, hitting that e button, raised to what I stored into alpha a there. And I get approximately 3.51. So there you have it. I know it's a lot of explaining over the computer there, but hopefully plugging the numbers in wasn't too bad. That part should have been review. And we look forward to seeing you tomorrow. Have a great night.